Hi, everyone. Thanks for coming to hear this talk. My name is Artem Tsvetkov. I'm a senior security engineer at Skyscanner, and we're all about making awesome products for the traveler. We are app first, and so we provide our app on all major platforms. And we operate our services in Amazon Cloud. And as a security engineer, I get to spend a lot of my time playing around in that. And it's pretty awesome and interesting. And so today I want to talk about AWS serverless security and present Half-Life, which is a little auditing tool that I made for Lambdas. What's a serverless? Well, it's called a serverless, right? But there's a server, really. The thing is just you don't have to manage any of it. It's all taken care of by Amazon, and all you have to do is upload your code, set up some event sources to trigger that code, set up some permissions, and then you're good to go. And what's a Lambda? Well, a Lambda is an event-driven serverless computing platform by Amazon. And the way it works is that it runs code in response to an event that you set up. It automatically scales with high availability, so you don't have to worry about denial of service or anything like this. It runs in an isolated environment with a read-only file system. It's one execution per request, and typically runs for a few seconds, but there's a 15-minute runtime limit. So the way Lambdas work is that they have versions and aliases, and basically this means that you can publish multiple versions of your Lambda and create these human-readable tags called aliases to each individual version, and that way you can have one version in production, one version in development, and seamlessly switch these once they're ready to be taken to production. Lambdas also have layers. And these layers is basically a way to avoid code duplication across multiple functions. So, for example, you can publish a layer with common logic like metrics, tracking, or authentication, or whatever. And then you simply reference this layer from your function, and that way you can share code. This is also a way to introduce third-party code to your Lambda functions. Lambdas run with an execution role, which basically identifies the function and controls its access to AWS resources. And apart from this identity-based execution role, other resources, including a Lambda, also have a resource-based policy, which also specifies what are the event sources for this function and what you can do with it. And if we take a look at an example here, on that side we have an S3 bucket, and then on this side we have the Lambda function. And what happens is that the user uploads a file to the S3 bucket, and there's a notification set up to notify the Lambda function and trigger it. And when the Lambda function runs, it uses an execution role that tells it what it can and can't do and who can trigger it and stuff. And then executes some code that you upload in there, and this code processes the file. And so all of this happens without you ever configuring any servers, or anything else. You just go into the management console, or you upload a CloudFormation or whatever, and all of this happens automatically. So a more interesting example is a microservice. So you've got your users going in through Route 53 at the top there. They resolve the domain name, and then they go to an S3 bucket, which has your static website. You also have there below Route 53, right there, you have your API gateway, which specifies the different endpoints that you can access. And each of these endpoints maps into a separate Lambda function. And because all of these probably share some common functionality, you can probably put that into a layer. And then these functions do stuff and maybe access your database and so on. And again, all of this is without you ever touching any server configuration, any software, any hardware. You just configure it like through a management console panel or whatever. And so this is great, right? You don't have to worry about patching your software. You don't have to worry about changing hardware. Everything is already fault tolerant and highly available by default. There's virtually unlimited scaling capacity in execution and in storage. You have an isolated network perimeter inside your VPC. And okay, but so now, this is really different from the typical setup with your servers and stuff. So how do we really, how can we check what's going on in there? How can we audit sort of the things that are happening? And yeah, again, AWS shared responsibility model states that AWS is going to take care of all the software and hardware stuff, and you have to take care of configuring your service. And so a huge part really about securing your Lambdas and serverless architecture is about configuration. And this configuration is hard. You need to set up permissions, you need to set up access controls, and there's a lot of stuff at play. There's users, roles, trusted entities, your access control lists, resource-based policies, managed policies, inline policies. And the first time you touch this, you're like, okay, well, that's too much stuff going on, and you really need to figure it out. And so really what happens is that people, developers who want to go fast and they really need to get things done, they don't normally take the time, or they're not aware of how to configure this well. So what they do is, for example, you have an SQSQ, right? And when you create it, there at the bottom, it tells you, okay, well, you have this SQSQ, but it doesn't have a policy, so you're the only person who can use this queue. And that's probably not what you want, right? You want your Lambda functions or your services to access this queue and use it in the way. So you need to set up a policy. And the easiest way to set it up is basically in 2 clicks. Everybody and all actions, add permission. So this allows everyone to do everything on your queue. And this will work, of course. It's gonna work. But it's not really secure, and we'll see why in a bit. And this in itself, the policy configuration, is really a unique serverless challenge, because now you don't have to worry about software and hardware, but you do have to worry about setting up all these permissions and connecting your services in the right way. And okay, giving all permissions to everybody is maybe okay in sandbox when you want to go fast and you want to develop your product and test it. But once you push it into production, you shouldn't really push it like this. You need to configure all your permissions, really following the least privilege principle. Otherwise, you might get public exposure of your S3 buckets, with information about your users and so on, as we have recently seen in the news. And just to briefly take a look at what's at play here for configuring a policy. Policies have an effect, which is allow or deny. So it's telling you, are you allowing or denying stuff? It has a principle, which specifies exactly who is affected by this policy. It could be a user, a role, a trusted entity, or whatever. The actions specify the actual things, the actual permissions that you're allowing or denying. Resource specifies what other AWS services you can or cannot access or use. And then finally, there's a condition, which is optional, and it specifies when the policy is in effect. And so the common pitfalls with that is, actions, unrestricted actions. These specify the permissions, and so at the top you see an example of specifying a specific action for downloading a file from an S3 bucket. And at the bottom, you see a wildcard being used with these actions. And so the wildcard basically says all of them, allow everything. And if your service is really meant to allow users to download stuff, well, that's really the only thing you should allow, because otherwise they will also be able to upload stuff to your S3 bucket, maybe abuse it to distribute malicious content, or they could maybe delete some stuff from your bucket, and so on. Another example is the unrestricted principle. So at the top, again, you see an example of specifying a concrete principle, saying, okay, this user account, my policy is about giving this user access or restricting this user in some way. And then at the bottom, you're basically saying, all right, everyone, doesn't matter who, public, not public, AWS user or not. Okay, well, it applies here. And then conditions, they're optional, but when you're allowing actions and then you're specifying a wildcard principle, that really makes your code or your function or your content public and available to everyone. And so unless you specify an additional condition, it's going to stay like that. And so this is an example of specifying a condition where you're restricting access by source IP. So maybe, for example, you have, I don't know, a lot of services, and there's no way for you to specify all the principals one by one. So you say, okay, I allow all principals, but only from this private subnet that I have. And so that would work. There are tons of ways to really screw this up. There's, allowing not principal, which is like allowing everyone but, allowing not action, allowing everything but. There's a lot of ways to not do well S3 access control lists, so you can use wildcards everywhere, and there's really a lot of stuff here at play. And so when we were looking at this at Skyscanner, we had serverless architectures running in production. And we said, okay, well, we want to see what's going on inside. We want to see what we have, and maybe do a security audit and see what's really how do we really have it set up. And so Half-Life is basically this Lambda auditing tool that's made to create asset visibility and security and help you improve security with actionable results. It has been released to public, has been open sourced just yesterday. And you can install it through pip, or you can download source code at GitHub. So check it out, and PRs are welcome, and so on. And yeah, so the way Half-Life works is basically it takes in a list of function errands. So you're saying, okay, audit all of them, or maybe there's one specific one that I want. And then using this function is going to find all the event sources for this function. It's going to find all the resources it uses, and then check the policies. How are those configured for the function, as well as all the resources and event sources. And it's going to also check some configurations, like, for example, is storage encrypted or not? And as you know, or maybe not, but in Amazon, everything comes for free regarding encryption. You can always enable it for free. So when it does that, you can also optionally enable static code analysis. So it's going to download your function code and run it through SonarQube in this case, because that's what we're using as Skyscanner. So I made it compatible with SonarQube. In GitHub, you actually have a Docker file to build a SonarQube server for yourself if you don't have one. On the output, you get these JSON and HTML reports that you can use either in some automatic system that you might have, or you might want to take a look at it yourself. So this is what you get when you run it from your terminal with verbose mode on. It's made to be run from terminal as well as, say, a cron job. Like you want to set it up and it runs every day or whatever. So you can turn off all the verbose output, of course. There's different switches you can specify. You can play around with it and see what it does. And these are some of the examples of the JSON output. So there's a statistics file, which is basically like tracking what you have going on with your Lambda function. So it's, for example, telling you the runtimes, how many functions do you have, what are the different runtimes, so you can see, okay, I have maybe like 17 old Python images that I might want to update, or whatever. Or you might see some, weird language popping up in there, some custom runtime that you might want to address. It's telling you, like, for example, security stuff, how many high detections, medium detections that I might want to take care of right away, and so on. This one's taken from the security JSON file, and here it's telling you for each item that it finds, it's basically telling you the function that this belongs to, the where, tells you exactly which event source or resource is affected by the vulnerability. Then, of course, the level and the text. So in this case, it's telling you, okay, you have a public S3 bucket that is affecting your Lambda function. So here the theory is that, okay, if I have a public S3 bucket, and somebody uploads some content that's not expected by my Lambda function, what's going to happen, and so on. And this is also Half-Life also generates per function report, and this is where you see all the details for each individual function, including, the description, the runtime, the region it's in. It's going to give you all the policies, including resource-based policies, your execution role, and so on. And this is basically the HTML version of the JSON reports. This is the stats that you see. Sort of nice to get an overview of what's going on inside your serverless network. This is the security part. So you get a list of all the vulnerabilities it finds all in one place. The middle column here would tell you where, and then the last column will give you a link to the Lambda function, and when you click it, it's going to lead you to this individual Lambda screen, where again you have all the details as well as the vulnerabilities that belong only to this function. And yeah, that's pretty much it. For the way it functions, there's a lot of improvements to be done, especially with the HTML report. I want to integrate Lambda layer analysis, because there you can introduce, for example, third-party code, which is important to keep track of and see what it does. More rules, extend static code analysis, maybe other tools, not just SonarQube, tons of bugs. Lots of stuff. Again, PRs are welcome. And that's pretty much it. Thank you for your time. And if you have any questions. Question over there.
If you identify a problem with a function and you release a new version to fix it, how can you make sure that everyone starts to use the new version and doesn't stick with the old one?
Because for you to use a version, it has to be, it has a latest tag. So by default, it's always the latest tag that's referenced. So unless you specifically calling some like version 1 or version 2, whatever, you're always going to use the latest. So you can revoke in what sense?
So if someone is deliberately calling version 2, for example, and you have version 3, you can say, okay, version 2 is no longer accessible.
No, I guess you could delete it, but normally you'd either be calling the latest, or you would make aliases, and then so you'd always be calling the prod alias, and that alias you change the mapping for it. Any other questions? Answers?
Hi. How are you extracting the source code of the functions?
When you using Boto3 or using the console, the AWS CLI, when you call function details, like to get the function details, it provides you a URL for download that you can use.
Okay, thank you.
Does it communicates through the AWS API, right? Do you have plans on including like Terraform files and not just communicating with the AWS API and scanning the vulnerabilities from Terraform files, for example?
To be honest, I haven't thought about Terraform at all, yeah, not sure. Maybe in the future, yeah.
Okay, thank you.
That's it?
Yeah.
No more questions? Yeah?
Okay.
Yeah?
Thank you.
All right, cool.